let's look at some multiplication things that I had not especially gone over. And let's look at the standard algorithm for multiplying, let's say, a 3-digit by a 2-digit number. Give me two numbers, 3-digit number. 752 by 30. Let's make it where we have a bigger number, so we have to do some regrouping. Okay, so what do we normally do? We do 7 times 2 is 14, and then we say carry 1, except that that 1 isn't a 1, it's a 10. And then we say 7 times 5 is 35, plus 1 is 36, and we carry the 3, but it's not really a 3. And what we were really doing was 7 times 50, not 7 times 5. So it becomes confusing. Okay, but let's keep going. 7 sevens are 49, and I'm a bit lazy, so I'm going to count on my fingers. 49, 50, 51, 52. Okay, we're okay with that. What level was I operating on? I was operating on level 3 because I said 7 sevens are 49. And I'm just being lazy by counting on 3. So, be aware of that when you do number levels. Okay, 3 times 2 is, we do this thing, right? 3 times 2 is 6. 3 times 5 is 15. And then I guess we put a 1 there. 3 times 7 is 21, 22. And now we add everything up, right? And we can put a comma there.
You missed a.
What did I miss?
20, it's 27, 8, 24.
Oh, sorry.
You're 100.
You're right. I'm on the spot. Here I am in front of the class messing up. 8. Okay. So, do you see where some of the confusion can come in, even if they know their multiplications? We're working with big numbers, and sometimes they kind of slip in their number level thinking, and it stops making sense. So I want to propose a different way of looking at this, 752 by 37. Let's look at it this way. 752. And the first thing I'm going to do is multiply it by 7. Okay? So I get 7 2s are 14, right? Which means if I have my 1s and my 10s and my 100s over here, okay? So I have 7 2s are 14, right? 7 times 50 is 350. We agree? And 7 times 700 is a whole lot of hundreds. It's 49 hundreds. So that kind of gives me the 7 part. Okay, so let me just add this quickly, and then I have 4, I have 60, 6 tens, and I have 12 hundreds. So that gives me that number. Okay? I now have to take my 752 and multiply it by 30. Okay, so what happens when I have 2 times 30? I have 60. I'm just going to call it 60. 50 times 30. 150. It's 1,500. 30 times 700. 21,000. And then I can add this up.
Why'd you do it like
I didn't have room further to the left.
Oh, I understand.
Okay, so I've got these big numbers, and then I can add them together. But this is a little bit more conceptually reasonable, but it's not friendly. Okay, so what's my head thinking? What was my number again? 752 times 37. Okay, where is my head going? My head is not functioning quite well. What I want to do is I want to look at this as 7. Let me erase this quickly. Okay, what I'd prefer to do is think about it this way. Here's my 752 in the hundreds, tens, and twos, hundreds, tens, and ones, and here's my tens and my ones. Okay, let's make some boxes in here like this. Okay, so if I start here, 2 times 7, 14. Okay, 2 times 30, because this is a 30. This is really a 30, right? This is a 700. This is a 50. 2 times 30 is 60. Okay. 50 times 30. 1,500. 50 times 7. Okay. 700 times 7. 700 times 30. 21,000. And then I can add them all together. I can line them up. And I can add them up. Does this kind of make sense? It's a little bit more reasonable. Comment, question? I think it might be a little clearer if we use a 2-digit by 2-digit instead of going all the way over there. But if we go back and look at what we did in the beginning, do I have all of these numbers in my multiplication process? So I'm looking at 5,264. Do I have that? I think this part over here, 5,000. Where did that come from? Hold on. That came from multiplying by 7s. Okay, so it came from this number, and this number. Okay? The other part that we did came from multiplying by the 30, the 22,560. It came from this, and this. So this is over here. This is the red stuff. So you see it kind of got broken down a little bit. Does this kind of make a little bit of sense? Would it be easier to look at a problem that's done with like 2 digits? Doing 3 digits was a bit tricky. Yeah. Let's go back here and look at 73 times 28. Okay? So, if I do 8 times 3, what do I get? 24. If I do 8 times 70, 560. If I do not 2 times 3, but 20 times 3, I get 60. And if I do 20 times 70, 1,400. think this is a little clearer than showing the 3 by 2. Do you see what I'm doing here? I'm being really particular about calling my tens numbers those. I'm not calling this a 2. I'm calling it a 20. Okay? So just to make a point on that. All right. Let's just look again. I had discussed a little bit about division last week, and a few people were absent, so I want to go back over let's look at that long division problem. What did they have to divide? 240 by how many? 17 or something. Okay? So one of the things I showed was the idea of 17 does not go into 2 is a problem because it's not a 2, it's a 200. And 17 does go into 200. And if we say 17 goes into 24 one time, that's also not correct because it's not 24, it's 240. So you see, sometimes this mathematical language that some math professor made up to do a very efficient way to do number operations is a problem for some kids. So an alternative way to think about this is, well, I think I can take away 17 one time. And on the side, I'm just going to keep track of how many 17s I take away from 240. That way, I am doing multiple subtractions, which is what division really is. Okay, so I'm going to keep track of it like this. And if I subtract, I know that I need to regroup here. This will be a 30 and this will be a 10. So I'll be left with 10 minus 7 is 3, and 23 minus 1 is 22. This is going to take a long time, and my little head says, wait a minute, I can do a bunch of 17s. I recognize I could maybe take away 10 17s all at once, and I know that that's 170. Okay, by the time they're doing long division in 4th grade, that kind of number set should be in place. Okay, so let's subtract here. And 20 minus 70 doesn't work, so let's do this. Okay, 12 minus 7 is 5. 53. Can I take 17 away again?
Yes.
I don't know how many times, so I'm just going to do 1. And I'll do the same thing. That's a 6, and that's a 3. I think I can go one more time. And I have to change this again to a 20, and this is a 16. And that's a 9. Oh, and I can go one more time. So altogether, 10, 11, 12, 13, 14. This is going to be 14, and there'll be a remainder of 2. Does this make sense? Okay, so just keep in mind that this is an alternate algorithm, and what I'm saying also is there's a whole chapter in the book that shows you a variety of algorithms and ways to reinforce standard operational things that have to be done beyond the basic understanding. And this is one of them, as is that other multiplication model. So I just want you to know where to go to find more. We don't have time to go through the whole book in this course, but it's there. It's a really good resource. Okay?